Now next topic, that is the radius of gyration. Now see, suppose we consider a rigid body rotating about the given rotational axis. Then we can give its moment of inertia I, that is m1 r1 square plus m2 r2 square up to mn rn square. Now suppose here mass of each and every constituent particle, that is same one, means m1 equal to m2 equal to m3 up to equal to mn, and say this mass is m. Then we can write mr1 square plus mr2 square plus up to mrn square. Here we can take m common, so m into r1 square plus r2 square up to plus rn square. Now here multiply and divide the equation by n, that is the number of constituent particles. So mn r1 square plus r2 square up to rn square divided by n. Now m, that is mass of one particle, n, that is total number of constituent particles. So mn will give you the total mass of the body. So we can write here mn, that is total mass, and this bracketed term, that is represented as k square, that is nothing but the average of r square, that is the average of r square. Now if we take the square root of this one, then k, that is under root r1 square plus r2 square up to rn square by n, then this particular term, that is known as radius of gyration. So here when we say I, that is equal to mk square, so here m, that is the total mass of the body. Clear? Now, so here we can give the definition of k. Like this, actually from this equation we can write the square root of the average of r square for the constituent particles of the body, that is known as radius of gyration. But as per its physical interpretation, we can give its definition like this: the radius of gyration of the body about an axis may be defined as the distance from the axis of a mass point whose mass is equal to the mass of given body and whose moment of inertia is equal to the moment of inertia of the given body. It implies that, let's try to understand this thing with the help of simple equation, simple example. See here, suppose we consider the case of the ring which we discussed previously. This is the ring. Now with respect to this rotational axis, right, its moment of inertia I, that is equal to mr square. Now here suppose we consider the same rotational axis. Now ring is suppose replaced by a point like mass. This mass is m. This mass is m. Now suppose this one is the distance of this point mass from the rotational axis, that is k. Then we can write in this particular case the moment of inertia I, that is equal to mk square, mass into square of perpendicular distance. Now if the moment of inertia of ring and this point like mass, that is same one, then we can say this particular perpendicular distance, that is the radius of gyration for the given rigid body. Clear to all of you?